Hello and welcome everyone to yet another Varnish software webinar. This one is called Top 10 Do's and Don'ts when caching with Varnish. Hi, my name is Thijs. You can probably see me in the camera as well. I'm the technical evangelist right here at Varnish Software, and I'm really glad that you took the time out of your busy schedules to be here with me. It's a bit of a cliche, but I love to use it because it's a sign of the times. Early March, when this entire COVID debacle kicked off, webinars were cool. Now we're, 6 months later, webinars are no longer cool, but we're still doing it and we're still trying to add value. And I know there's so much out there, so that's why I want to thank you for being here.
Yeah, hi, it's Ariana here, technical pre-sales and support operation managers at Varnish. And today I'm together with Thijs, and we do hope to give you practical hints on what to do and what not to do with Varnish. Please,
The goal
Thijs,
for
kick it
us
off.
is, our goal is to, I wouldn't say argue a bit, but there will be some healthy interaction between me and Ariana, and we'll try to keep it as lively as possible. So let's kick it off with the top 10 do's and don'ts. Now, it is important to know that we're not negative Nancy's. We're not going to go for all negative things. We did want to balance it out from the get-go and talk about 5 things you shouldn't do at first, and then 5 more positive points of what you could be doing to improve the situation. So let's start with number 1. Which sounds weird and counterintuitive, but it is important, I promise. Please do not set your TTL to 0. And let's start with a very common use case. Now, VCL, the programming language that comes with Varnish that allows you to tweak the behavior of the cache, you could write the following VCL. Now, VCL backend response is a subroutine that hooks into the finite state machine and that allows you to extend the behavior when it comes to backend responses and receiving backend responses. In this very example, we're looking at the content type response header that comes from a response we got from the origin. And if it contains image, so if it matches a regular expression that starts with image, we're clearly dealing with images and we want those to be cached for 3 hours. So what we can do is set the backend response TTL to 3 hours. It's a very common use case. And here's where it gets tricky. If you follow that analogy and you say, I do not want to cache things, you could say, if my cache control header that I receive contains no cache, no store, or private, we're going to set the TTL to 0, not to cache. Seems very intuitive, seems very straightforward, but please don't do this.
Yeah, and I'm gonna give you a bit of a technical overview on why this is really, really bad. So the problem we're trying to solve here is that sometimes we want Varnish not to cache content. But really the proper angle is that Varnish is caching software and it is optimized to do caching and to do it well. So I'll explain one of the most important features we have in Varnish by using an example. The feature is called request coalescing, and its goal really is to avoid overwhelming the origin servers and your backends in general. So let's say we have 1,000 concurrent users, all of them requesting the same piece of content. That's a typical use case for Varnish. High load, users requesting the same content. What happens if the content is not in cache? Varnish will take these 1,000 users, and out of these 1,000, Varnish will trigger a single backend request. This is some sort of a funnel where a single backend request is issued towards the backend, and the other 999 users will just wait in line pending for Varnish to fetch the content from the origin server. And as soon as the content is in cache, Varnish will just broadcast it over to the other 999 user being put on a waiting list state. And that's really how we make sure performances are extremely good. While if you, can you please move to the next slide?
Yeah,
Thijs?
that's what.
Thank
What I
you.
would like to add about this is a lot of products, caching products, don't have this request coalescing feature in place. And what happens is, as soon as something is not in cache that is requested, this sort of cache stampeding pops up, where all these requests trigger so many backend requests that the origin goes down. So our priority is to keep the origin stable and protected, and that's why request coalescing is such an important feature. Now, however, as Ariana mentioned, there is this side effect of the waiting list that we created, and if you set your TTL to 0, you run into trouble.
Exactly. So the problem with setting a time to leave equal to 0 is that basically we are instructing Varnish to fetch the content from the backend and discard it immediately. So in the same example as before, if we have 1,000 users, a single one of them issue a backend fetch, and the other 999 will just wait for content to be in cache. And what happens here is that Varnish will retrieve the content, insert it in cache, and prior to delivering it to the 999 remaining users, it will check if the content is still valid. And given that Varnish will find that time to leave equal to 0, then that content can't be used to fulfill request anymore, and then it will be just thrown away and discarded. And the 999 pending users will just wait in the waiting list queue, and Varnish will process them one after the other in a serial way, and this will obviously
that's really
slow
bad.
down.
Yeah, it's super bad
terrible.
performance, because you're pretty much at the mercy of the performance of your origin, because this is done serially. We call it serialization. If a request takes 2 seconds to load, if you have a slow origin and there's 1,000 requests in there, or the last one has to wait about 2,000 seconds. Now, I'm pretty sure you'll hit some timeout before that happens, but in terms of user experience, that's really poor. So serialization is something we try to avoid at all costs. And we tackle this issue with the following construct.
Yeah. Do you want me? I can elaborate on this, because really the logic behind this VCL snippets, and please Thijs, feel free to interrupt me or chime in at any time. But in this VCL snippet, what we are basically telling Varnish is, please do remember that any content with a cache control matching no cache, no store, or private cannot be cached for under 20 seconds. So basically, we are in Varnish, we are caching. We're telling Varnish to cache, or the idea to not cache for 2 minutes for private content, really.
And that idea we call hit for miss, which means that for the next 120 seconds, as you can see, Varnish will cache the decision not to cache, and that will cause the future request to actually bypass that waiting list, because we know it will never be fulfilled based on that request coalescing promise, because it's a pass. Only misses can, and a miss is actually a good thing. A miss is a hit that hasn't happened yet. So from that respect, we know it will be fulfilled by the waiting list and by request coalescing. However, if we set something to uncacheable, we actually bypass that entire mechanism and directly connect with the origin, which is our intention.
Yeah,
so
exactly.
I hope this makes sense by now, that if you don't want to cache, please cache the decision not to cache. Sounds counterintuitive, but from our perspective, it makes a lot of sense, and you'll reap the rewards from it.
If I may add, just to conclude on number 1, you can also use TTL very close to 0, so 0.2 seconds. That will be a valid TTL. But from a human point of view, that will be extremely close to not caching at all. So that's also something you may want to consider when drafting the caching policy.
Now, one thing that has changed over the years is this used to be, we call this hit for miss now, it used to be hit for pass. So if it was hit for pass, that mechanism kept you in there in the uncacheable state for 2 minutes. Even though if the content on the next fetch became cacheable, it was still ignored for 2 minutes, so you're stuck in that. This has been changed to hit for miss, which means you will be bypassing the waiting list unless a cacheable response comes in. So you can actually escape that cache bypassing and eventually leverage request coalescing again as soon as the next hit comes in. So that's a good one. All right, that was number 1. One thing you shouldn't do is setting the TTL to 0. Please also don't skip the built-in VCL. There's this concept of the built-in VCL, that is VCL code that is written behind the scenes and that is included in the different stages of VCL. So it's some sort of a safety net, and it's quite important. I remember it from my early days. I've been working with Varnish since 2010, I guess. And back in the day, I didn't know that a thing like built-in VCL existed. So I started typing all sorts of stuff, and weird behavior occurred, because it didn't occur to me that all these default things that people mentioned are part of the default VCL, the built-in VCL. And maybe I should show some code. Like, this is what built-in VCL looks like. And even though that code would not be there, it would still behave in such a way. Now, allow me to elaborate. This is VCL receive. This subroutine is called that way. And that is a mechanism to hook into receiving requests. Now, if you would write some custom VCL and would do a custom return statement, if you do, like, you can see different return statements: return pos, return hash, return pipe, return sint. If you would do in your custom code any of these returns, you would be bypassing default behavior. So my advice is to try to leverage that built-in VCL as much as possible by not returning unless you have exceptional behavior. If you have custom behavior in your VCL, write it, do your return statement. For anything else, please rely on the built-in VCL. Now, I will quickly explain what this does so that you understand how much of a safety net it is. Like, it starts with this first if statement. If the request method equals pry, then we return synthetically 405. What does a synthetic return mean? It means that we're not returning data that originated from the origin server, but we're returning something explicitly ourselves. And for those of you who are familiar with HTTP requests or response statuses, 405 means method not allowed. So if the request method equals pry is part of the HTTP2 spec, that means you're actually doing HTTP2 based content on a system that doesn't understand HTTP2. However, Varnish does understand HTTP2 if you enable it. If you enable HTTP2, that pry will never arrive. So it's a bit of an anomaly. And then the next one is if you do a request that uses the HTTP 1.1 protocol and you're at the base level, meaning you're not doing any sub requests, meaning that the ESI level is 0, and you don't have a host, then we'll consider it as a bogus request, because every request should have a host header, and then we'll return 400. You're up next, Ariana. What's with the next segment here?
Yeah, so like for the pipe one, we're basically telling Varnish to not handle any request which comes in with a method different from the one provided by the official RFCs. And that's basically because we don't want to cache content which may be malicious content, and we just pipe it over to the backend, and the backend will take care of it. Typically, or the WAF or any web application firewall will actually just reject malicious requests. And the same goes for method different from a get or head request. We don't want to cache, for example, post request, which most likely may be a login page where the user is providing a username and password. We don't really want to cache this kind of content.
No, not at all. Because, and there's a difference between, you see get and head do a pass, and if the request method is not recognized, we do a pipe. There's a difference between pass and pipe. Pass is just bypassing the caching mechanism and going straight to the backend, whereas piping just completely gives up on HTTP. So if you do a return pipe, all the knowledge we have and all the intelligence regarding the HTTP protocol just goes out of the window, and you're just dealing with the backend as a just TCP device. You're just shuttling bytes over TCP, which is dangerous. So you should only do it if you think that whatever you're getting in is garbage and cannot be considered HTTP. And all the rest, well, then we can do a pass or a hash, as you can see.
I agree. Like, passing is typically the best approach, because Varnish can also be used as a shield for your origin server. So if there is anything funky going on, you can use the cache to reject or protect your backend. And that's absolutely
great. And you can also
great.
see some more default behavior. If there's a request header named authorization or a request header named cookie, we don't want to cache either. And that seems weird, because a lot of, like 99.999% of all the websites do have cookies. But pure from a theoretical perspective, as soon as a cookie arrives, or an authorization header for that matter, you're dealing with personalized content, state is involved, and you can't really assume that whatever you'll be serving will be like good enough to serve to everyone. It will be content for your eyes only, so we don't want to cache this. Now, in reality, cookies will always occur, so you'll have some custom logic in there to deal with specific cookies or to strip off specific cookies. But if not, you can still rely on built-in VCL to take in account conventional behavior and disregard cookies and not cache if cookies are present. And there's just one method remaining, or one return statement remaining, Ariana.
Yeah, and that's the return hash. And that's where Varnish will indeed start the cache lookup or the cache insertion for new objects. And this brings me to the next slide, and one of my favorite subroutine, and that's VCL hash. So that's where Varnish generates the hash keys for new content to be inserted in cache or for the cache lookups. And by default, we use the request URL and the host name if present, otherwise the server IP if the host name is not there. And throughout the years, I've seen that this subroutine is one of the subroutine most modified by the Varnish users, and I'm still unsure. I still don't really get why users will want to request on a single header and not keep into account the request URL, the host name, and the server IP. These three fields are supposed to be unique.
Yeah, indeed. And it's a matter of cardinality as well in the cache. So if you start adding things to it, and you can, like VCL offers you that behavior, you should keep into account that this creates this sort of variation, as we call it, for whatever you're storing in cache. So let's say you have, for example, a language cookie. If you have a language cookie, let's say you have a splash screen where you do the language selection, and that selected language gets stored in a language cookie. Well, given the proper codes in VCL, you can actually extract the language from it and create a variation. That's a very good one. But if you start hashing on all cookies, all bets are off, because then you have too many variations, and VCL hash will make sure that your hit rate drops dramatically.
Exactly, because that leads to cache fragmentation, which basically means that you will get the performance degradation, and you will probably have also a waste of the resources available you have. And as a general rule, I'd say there is no correct or wrong when generating hashing keys, but whenever we insert content in cache, and the strategy we use to insert content in cache, we also need to have the symmetrical of it, which means that we need to be able to add content in cache, but at the same time, we also need to be able to remove content from cache anytime we want. So that's something you need to keep into consideration when changing the structure of VCL hash.
One minor detail for those who paid attention, you can see if a request, we're still in VCL hash, by the way, if the rec.http.host is set, so if a host header is set, we'll use the host. If not, we'll use the server IP. Now, in the previous slide, I just want to show that to you. If you don't have a rec.http.host and you're using HTTP 1.1, you'll be getting an error. So that means if you're ending in that second path, that second cove path, hashing the server IP, that probably means you're using HTTP 1.0, but that's just a detail here. Right, Ariana, you agree with this, or see other use cases?
No, that's
probably HTTP 1.0 or 0.9, which brings us to the next one, VCL hit. So the VCL hit subroutine extends or sets the behavior rather of how you should deal with hits. Now, normally, obj.ttl means the object's time to live. That is not the time to live that was initially set, but it's the remaining time to live. So that's how long will this object be in cache for. If that's greater or equal to 0, you're still good. And you're dealing with, and that's the way we officially call it, an unadulterated hit, and we just deliver that. No need to contact the origin, just deliver it from cache. However, if your TTL equals 0 or is less than 0, that means the object has expired already. Usually that would imply that you connect to the origin and get a revalidated object, get the updated object. But we have this concept internally called grace mode, and this is also a counter. I think that defaults to 10 seconds, if I'm not mistaken. Please correct me, Ariana, or look it up. And what you see in the second if statement is if the remaining TTL, even if it's negative or equal to 0, and if you add grace to it, which is the sort of extra TTL you give it, and if that's greater than 0, you can still deliver it. But it's not a clean deliver. Although the data is delivered, a background fetch is made for the most recent object. And that is our implementation of what officially is called stale while revalidate. So while we are revalidating, we are still delivering stale content. And that greatly increases the user experience, because if a user comes across expired content, he or she shouldn't wait for maybe a slow backend. You'll get old content while we are fetching, which is a really good one. And then if that has expired as well, we're dealing with a miss. Now, what is not in this VCL code and what does happen in the core in the background, if TTL and grace have expired, we have a third counter called keep, object.keep, and that also can add time to it. If that one is set, we'll keep the object around for conditional requests, as we call it. So you can do e-tag checks, if non-match checks, and we'll keep the object around, but that is done synchronously, while if you still have grace mode left, it's done asynchronously. So a summary of this subroutine is that we apply a little bit of intelligence to hits to check if whatever is served from cache is not outdated, and we provide sort of elegant ways of delivering the content without burdening the end user. So that was that.
Yeah,
But
quick
there's
tip
more.
before. Oh, sorry, I wanted to
Yeah, go for
suggest
it. Go for it.
to our viewers, like quick tip, like if you need to tune the TTL or the grace period of an object already in cache, that is doable, but instead of doing all the calculation within the VCL itself, I will suggest to use a Varnish module we have, which is called vmode stale, whose goal is indeed to provide an API to tune the TTLs and the grace times of objects already in cache.
Yeah, it allows you to rearm the object, in fact. And but warning, this is an enterprise-only module, so that means you have to have a subscription with. So for Varnish Cache open source users, this is not a viable solution. What is a viable solution to tune the grace, if you want to, is I talked about our implementation of stale while revalidate. Well, in fact, if you use a cache control header in your application and you use stale while revalidate and assign a value to it, Varnish will respect that and will assign this to grace. So that is also a plan B. All right, let's go to the next one. What's up here?
That's pretty good. One of the smoothest part of VCL. Well, the backend fetch really is the subroutine initiating the backend fetch of a piece of content of a URL. And typically, it's pretty intuitive to think that whenever we have a request method different from get, then we are going to discard the backend the request body, and then really all it does is just initiating a backend fetch, and eventually here you can tune or you can change the backends for Varnish to connect to, and so on and so forth. But that's really pretty much it. On the other side, we have the VCL backend response, and that's, in my opinion, and I think Thijs, you would agree with me,
Wait until you give your statement. You say, I would agree. Let's hear what you have to say first before I agree.
It's one of the most important subroutines we have in.
I fully agree. I fully agree.
Very well. Very well. That's really where where Varnish is inserting content in cache, and that's the place where you need to act on the content you are retrieving from the backend. That's a single subroutine where you can slightly change the parameters of an object. Once the object is in cache, then that one is immutable, and you can't apply any strong changes unless you do use specific Varnish modules. And the default behavior of VCL backend responses really is a safety net. So
yeah,
if the
indeed,
content is a cacheable, yep.
Yeah, I'll take it from here. If the content, if the TTL is less or equal than 0, that means you probably had an expires header that was set in the past, or a cache control header where the max age or Smax stage were 0. From a stateful point of view, if the backend sets a cookie, that probably means that state is about to change, so you don't want to cache that. Surrogate control headers, which Varnish also respects. If there's no store in there, well, then we won't cache. If there's no surrogate control header, but a cache control header, no cache, no store, or private, will trigger objects to be uncacheable. And if you pay close attention to our first point of business, order of business, being don't set the TTL to 0, you'll see that come back here with a TTL of 120 seconds and uncacheable true. And the final bit of the puzzle, final piece of the puzzle rather, is if you have a vary header that is built to create specific variations, and we'll talk about variations in a minute. If the value is asterisk, that means you're varying on every single header. Well, we don't want to be caching that behavior as well. And apart from that, we store the object in cache and we deliver it immediately. So bottom line here, there's plenty more built-in VCL, but those were the most important parts. Please do not skip the built-in VCL unless you have to, but by all means extend it. Like write a little bit of VCL that is suited for your use case, that deals with the kind of cookies you want, with allowing certain things to be cached and other things to not be cached. But don't reinvent a wheel and implement all this low-level logic, because it's there for you. The built-in VCL is a safety net. Use it. And this immediately brings us, look, what a segue, immediately brings us to the following one. Please do not vary on the user agent, which allows a little bit of intro. So what, in fact, is the user agent, Ariana?
So if you want to move to the next slide, that will be
I will definitely show you.
Yes.
I was building up tension.
Yes. So the user agent is an HTTP request header, which is used by the browser or really any sort of a device or application you're using to watch or retrieve content from the internet to identify itself. So in this example, we have Mozilla presenting itself and presenting itself and saying that it is a Mac laptop and the operative system it has, the kind of browser we're using and we are entitled to use, and so on and so forth. And literally, there are thousands of or hundreds of thousands of different user agents out there. They are very much dependent on the browser you're using, the version of the browser you have, the region you are living in, the laptop or the smart TV you're using, and so on and so forth.
And let's explain what a cache variation is then. So we know what a user agent is. A cache variation, let's start with this assumption or with this fact. And you've seen it by looking at the VCL hash subroutine. Objects in the cache are identified by a URL and a host name. That you saw, right? But oh, look, here it comes again. Look, hash data reg.url and hash data reg HTTP host. Now, the wrong assumption that people may have is that if you store something in cache, cacheable pages will display the same output for every single user, and that is not always the case. And this is where variations come into play. Imagine that whatever is displayed for a specific URL, knowing that the URL and the host header form the unique key for that page, well, if that depends on an extra header, for example, the language header, well, then you're in a bit of trouble. Like in this case, the browser, the client supports ENUS and NLBE, so Dutch in Belgium and English in the United States, supported languages. And then the application might listen for that header, inspect those, and then formulate what the correct language would be. But if you cache this page, well, the first one will hit it. So if the first one speaks English and the page is in English and the next one speaks Dutch, he or she will see an English speaking page. So that's not the intention, that's not the goal. And the way to tackle this is by issuing a vary response header. And the vary response header as a value takes a valid request header. So with this response, what we're doing is saying, yes, I very much would like to cache the home page for the local host, but bear in mind that we need a variation for the accept language, which will then create different sub-objects and will make sure that based on that language header, you will see what you need to see. Bringing this back to the user agent, Ariana, this kind of sucks, right? You said that there were like literally thousands of user agents.
It's terrible. It's way worse than caching based on cookie headers. There are more variations to the user agent, and it's more disruptive than the caching on cookie headers. It's so absolutely don't do that.
No, don't do it. And the solution is there's realistic solutions. Like you can sanitize the user agent string to reduce the variations. Like if you have intelligence in VCL for that, you can actually say, well, here's a list of patterns where we know this is a regular browser or this is a tablet or this is a phone. Like you can use that if you want to have different representations, but it involves a little bit of work. And if you're on Varnish Enterprise, you can use our device atlas vmod that does this out of the box with a single function for you. So that's the solution. Up to the next one. Please do not use the Varnish's built-in file storage mechanism. This is how you assign where things need to be cached and which storage mechanism it needs to happen. It's malloc, memory allocation, and in this case, I assigned 50 gigabytes. But if you want more data, if you want to have more data stored in there, you might want to use the file stevedore, as we call it, the file storage mechanism, and store it on disk, because usually we have a lot more disk available than we have memory available. But here's the danger.
Yeah, it is absolutely non-persistent. So if I may present a bit about the file storage, this was originally started more than, well, now we're talking more than 6 years ago. And that was just a prototype, just to test what we could do with a file system in place, but it never really became a proper solution. And nowadays we have this still alive in the open source project, which is not performing well, because, well, you get the limited performances of a file system, and furthermore it doesn't persist over restart, and it is very prone to fragmentation. So my
Which
piece
will
of
kill you in the
advice.
long run, right? In the long run, like it might work in the beginning, but in the long run, it will just
Yeah,
kill performance as you grow.
exactly. And if you need to fix that, you will need to restart the cache. But given it's not persistent, you won't get the benefit of it. So it's a
No.
just never-ending cycle, really. Yeah, and the proper solution here will be to consider using the massive storage engine, which is enterprise only. And really, this solution comes with benefits from both disk and RAM memory. With MSC, you can have persistent cache, and to do that, we leverage the disk available on your machine. But at the same time, MSC not only uses disk caching, but it also comes with a RAM layer, so that we could still leverage the speed of RAM memory. So basically what happens there is that we are going to store all the content we're able to store on disk, and that will persist cache restarts, it will persist server power outages, unexpected server reboots, maintenance, and anything else you can think of. But also,
On top of that, it's important to know that this disk storage, we always consider disk to be the slowest part of our system. Well, we're not storing it on file per se. We're not outsourcing this responsibility to the kernel, to the operating system, because we know it won't work, and that's what the file stevedore does. What we've done, we've created an override of certain kernel modules and develop them in user space to actually tackle these. So the files in which we're storing are large pre-allocated files that are left open constantly, where we stream data through. So it's not a matter of opening a file, writing it to a file, putting it on disk, having fragmentation. There's algorithms in there that allocate data accordingly. It's files that are like, if let's say you have 50 gigabytes worth of storage, well, we'll pre-allocate one file that is 50 gigabytes and just stream data through, and it will be a lot less painful than doing that. And the rest, as Ariana said, is just stored in memory. On to the next one. Please don't reinvent the wheel, which is a common phrase used in IT, but instead please use VMods. And VMods is short for Varnish modules. These are modules written in C, and they expose an API that is usable in VCL. So basically, by using VMods, you get extra functionality in VCL. Because right here's the problem. I'm not sure if you've ever experienced this, Ariana, but like I try to write prior to knowing about VCL and about VMods rather. I try to do as much as I could in VCL. It's not always a good idea.
Yeah, absolutely. Especially the very last point there. Using inline C is dangerous. I'd say it is dangerous because it is difficult to test inline C. So inline C allows you to write C code from within VCL, but then it suddenly becomes close to impossible to test it and make sure it works as expected. And in most cases, it is dangerous and difficult to maintain, and so on and so forth. So,
well, luckily in modern
absolutely.
versions of Varnish, we have disabled it by default. And if you really want it, you have to enable it with a runtime flag, because otherwise it's just a disaster waiting to happen. But the reason why people write inline C is because sometimes they can't just write it in VCL. VCL doesn't have the APIs or the capabilities of doing certain tasks. And if it can, sometimes it requires a tremendous amount of VCL to get that done. So that's why we invented VMods. Like, imagine the following example. It's a bit of an exaggeration here, but say that you want to create an API gateway pattern where you want to terminate the authorization before you enter the application. So you want to make sure that Varnish checks whether or not you're authorized rather, but organizing this is a little bit of a mess, as you can see. As users come and go, you constantly need to update all that VCL. Let's say all of a sudden you have 100 extra users, well, that will require 100 extra lines. Also with the password there, it's not really good. So what you could do as a solution is use a vmod. And this is exactly how vmods are used. You use the import keyword, you name the module that is installed on your system, and then you can run it. So what this does, this is the equivalent. You do a basic auth.match, and you store all the passwords and usernames in the typical htpaswd file, and you're good. So it reduces the line count, and you actually outsource it to modules that were built for the job. Here's another one. Like you can accept connections using the proxy protocol, which is an extension of the TCP packet that contains the connection of the original IP. So if you have multiple proxies in front of one another, sometimes tricky to know what the IP address was and which protocol was used. And what this allows you to do is just determine the system in front of me. It was probably a TLS termination proxy. Was the connection done over HTTP or over HTTPS? So this module allows you to do that. This is logic that would be otherwise quite hard to implement in VCL. And again, this is just an example. Here it is, Ariana. Here's your dreaded inline C.
Yes, that's what I don't really like to see when reviewing VCLs. So this is a fairly simple example, really. So the idea is that if you want to write to the syslog, you will be really tempted to write a quick hack using inline C. And that's how you will do that. But really, we have a vmod for that as well. That's a standard vmod. But the general idea is that we have many vmods really, and we know that and our goal is to expand the Varnish capabilities, and to do so, we tend to write Varnish modules pretty much continuously, listening to what you guys have to suggest and what the typical what will be good for different use cases and different industries. And that's because we strongly believe that an API is easier to use and adopt in a production setup. It's easier to test, it's easier to integrate, it's easier to maintain, and it is also officially developed and maintained by us, which is typically really good because we are a bunch of engineers reviewing the code all the time. So please don't use inline C. Just drop me a message if you have any specific needs, and we can discuss it.
Yes, because it's very important. What the nuance that Ariana gave there is that we're very eager to develop vmods that are there for your use case. But if that use case is a powerful one and a pretty general one that we can recycle, we'll be even more willing to write the vmod because then we could reuse it. But the emphasis here is that we is not Varnish Cache. Varnish Cache is the open source project. It has a different structure and different rules, whereas that is Varnish Software, the company behind Varnish Enterprise. So we have a commercial agenda. However, there's still some vmods being packed in the open source version, like the standard vmod, which has a plethora of utility functions that you can use, from file system access, environment variables, casting, from data type, string interaction, logging, you name it. Vmod blob that gives you access to binary large objects. Vmod cookie was a recent addition that allows you to do simple interaction with cookies. Directors is a load balancing vmod. Vmod proxy, I showed you, is interaction with the proxy protocol. Vmod purge is there to purge. Vmod Unix is to interact with Unix domain sockets, and VTC is there, contains utility functions for test cases. And there's more, right? Like, this is what Ariana talked about. We hardly have any time to go over all of these, but yeah, it's a big list of very useful things that we can do. And they're all packaged with Varnish Enterprise. And here's the second page. It comes and goes. But what is also interesting is, although most of the vmods are maintained by us, there is a community out there of vmod writers and an ecosystem of people who write vmods that weren't necessarily affiliated with Varnish Software. And there's a couple of really good ones out there. So if you're looking for good vmods, have a look at the varnishcache.org/vmods page, and you might find what you need. Right, this is one of my favorites here. Number 6, please use Varnish's shared memory logging mechanism.
I could talk
what is Varnish log?
about that for 2 hours.
Yeah, me too. Like I wrote a blog post that took me like 3 days to write about it. So we're very passionate about this. But since you're so passionate about it, why don't you kick it off, Ariana?
Yeah, sure. So Varnish log, in my very personal opinion, is one of the best tools we have. Its goal really is to display and print logs from the shared memory log. It is extremely verbose, and I say that for real. It's again
Let's see if
amongst
I
one of
have.
the tools.
Look,
Yes.
this is what we have. This is verbosity. Like this is a 2-pager of. This is for a single request. This is what you get. So you're absolutely right. It's super verbose. But that's what makes it so good.
Exactly. I totally agree. It is extremely verbose, and because of that, we can't really write the logs to disk, because as soon as you get a bit of load on your Varnish machine, that the Varnish log would fill your disk. So we write that to memory and to a buffer which is clean once we reach the 80 megabyte by default, I think. And
Yeah.
because of that, really, it is extremely important to investigate and to understand how to filter out the valuable information from the Varnish log. And with valuable information, it really means everything and all, depending on the specific use cases. The most I've heard from several customers or Varnish users will be to check the response times, for example, the availability of a backend, the response status, and so on and so forth. So it is fundamental to understand how to query the Varnish log and which kind of information you are interested
Absolutely.
in reviewing.
And even if you're not planning to cache with Varnish, I would still advise you to put a Varnish in front of it solely for these tools, because this is unprecedented how much, or unparalleled rather, how much information you get. Like this one clearly shows tags on the left-hand side. Like you see the request coming in. It was a GET request on the homepage for the local host done with the curl user agent, and that got received, and it was deemed cacheable because there was no cookies, no post, put, patch, or whatever. It got hashed, it got looked up. As you can see with the VCL call, it was a miss, unfortunately. It wasn't yet in cache, and then we fetched it. And then timestamp wise, you can see that we're talking about microseconds here until these things were loaded, and then all the content is returned. And because my curl command line browser wasn't activated with gzip, we actually unzipped it. So all that information is there, and it keeps on going. Like this is the backend request that was made. So extremely verbose, but yet a little bit dangerous to that respect. But what you can do, and that is what makes Varnish log, both Ariana and me it's our favorite tool, is you can filter things out. You can limit the output. So in this case, we only care about the request URL and what happened behind the scenes. So this is it. Care to elaborate what happened here, Ariana?
Yeah, that's basically the same request you presented 30 seconds ago, but with a filter applied to it, just to understand the workflow and the pipeline here. So we get a request, and then we have a backend request. The request has ID number 10, and the backend request has ID number 11. As you can see, they are concatenated, so one is initiated by the other, and that's extremely important when you do filtering on Varnish log, or when you do debugging with Varnish log, because Varnish log really is one of the main tools we use when doing debugging on real setups. But
And
what's
what you can see here in this scenario is that this is actually a good scenario, because although it was a miss is good, because I told you before a miss is a hit that didn't happen yet. So nothing is really bypassed. So this, I'll show you the command again, will help you just to see what's going on for URLs, what VCL path is taken, and what the behavior will be. But there's more. Like we can filter out specifically the accept language header by using -I uppercase, and then you will get things like this. We get a request that has an accept language EN, and then we have a more elaborate one which comes from my Chrome browser, which is my setup. So you can inspect what languages people use, and it goes on and on and on. Like you have various commands. Care to elaborate on the top one, Ariana?
Yeah. Well, the first one really, or the -I the dash I parameter allows you to filter on specific varnish log tags, and you can see the tags in the main page for the VSL, which stands for varnish shared log. And then we have the dash Q parameter, which instead allows you to define the queries that you want to apply to the varnish log output. But if I may, I have two tips here. The first one is that varnish log has a JSON output, extremely important if you need to feed the output to any external tool. And the second one is that given the filtering and the querying on varnish log can become pretty difficult to do, especially if you're a newbie. We have on our docs.varnishsoftware.com website, we have a tutorial for varnish log filtering. That's a good starting point because there are varnish log commands for the most important filtering options you may want to
because the
apply.
filtering is very useful because like the minus i's are tagged, so it reduces the size of a single transaction, but minus q actually throws out transactions that don't match the pattern. And if there's still too much traffic, like in this case, the top one, we're looking at the home page and getting the flow for the home page. But even if that gets too much, you can rate limit the output so you get a subset. And the second one gets the URL of all the requests that were either a miss or a pass, so things that were inserted from cache. So it's a lot of use cases you can tackle with this. And the final one displays the URL and the timestamp for all requests that took longer than a second. So you can even check the speed and filter out slow requests, which is very powerful. So I hope we convinced you of that. There's also Varnish Top, which does pretty much the same, but in a top way. It's like running top on Linux. It shows the most popular tags. So if you do varnish top minus I rec URL, you'll get the most consumed URLs on a system. So in my test case, those were those. So you can see test is not that popular. This PNG file is a bit more popular, and the homepage is even more popular. So that gives you an idea of what's going on. And you can use the same language, same filtering to get the most hits, the most misses, the most passes, the URLs of all the top URLs that are too slow, different requests languages that were used. So the same power you have with Varnish Log, you have with Varnish Top. And finally, the final tool in our arsenal of VSL, of Varnish Shared Memory Logs, is Varnish NCSA. So what this does, and jump in, Ariana, as soon as you have a remark, what this does is it gives you NCSA style output, which is the logging format of Apache. So what we're doing is providing a surrogate for Apache logging.
Yeah, sometimes it is enough to have a one-line log output per request, and it can be useful to cross-check your actual web server logs together with the Varnish logs to make sure that Varnish is indeed caching what it is supposed to be caching, and in the right way as well.
Yeah, and what this does is it's let's go over the parameters really quickly. Minus A is append, so you append it to a file. Minus G request is you group everything based on the request. Minus R uppercase is a rate limiting parameter. So because you have so much content, maybe you have millions of requests coming in, you only want to get 100 every 2 minutes, and you'll write those to the log file. So Varnish NCSA, you can even daemonize this and run this as a service, and you could log rotate it, all the typical operational things you should do. And this is the output. This is what you get, which looks extremely similar to your Apache or Nginx logs because it's the same format. Speaking of which, this is the format that is used, and you can extend that format if you want to. So on the documentation page of Varnish Cache, you'll find that this format is used. You can actually extend the format and start adding custom fields. And there's a ton of them, and we don't have time to cover them all. This shows you the loading time, how much time it took to load that page. Or you can use handling to see what happened behind the scenes in VCL. So maybe a little remark, you can use the minus F uppercase parameter to display the format or to set the format. And we've added the handling Varnish variable. And as you can see here, these logs will then contain an extra field with either pass, miss, hit, and then we know what's going on. It gives you extra information, which is extremely useful. So what about this one?
Yeah, this one will run Varnish NCSA with a query on the response header on the content type response header matching the word image really and the slash. So you can do filtering on Varnish and CSA as well.
Yeah.
Everything I've said regarding Varnish log, so the JSON output and the filtering can also be applied to Varnish and CSA, because we know
And
logging
this one will just yeah, and this one will just output all the images. We'll create lines for images. Next up, please
another
do
good
memory
one.
management. Yeah. So we're going to pick up the pace a bit, because I'm looking at the time. Memory management is important, and sizing is a big part of it. It's always tricky, and I think Ariana has more experience with this than I do. I'm the evangelist, but Ariana is actually in the field and is faced with sizing problems on a daily basis. And do you want to do this, or do I explain this one? How do you want to proceed?
Please go ahead. I'll chime in with unexpected things.
So what we have here is a typical use case where you have a server that has, in this case, 90 gigabytes, but you don't want to consume all the memory for caching objects. So we'll leave a bit of headroom, 10 gigabytes in this case, and the 80, that's the plan, to keep 80 for cached objects. But people often don't know that there's a runtime cost associated with using Varnish. So that means that there might be object overhead, a little bit of object overhead, but if you have lots of objects, that will grow. If you have lots of requests coming in, well, that workspace client memory can increase as well. If you do costly actions in VCL, that will grow as well. So that's eating out of your headroom. That is taking away space and leaves you, in this case, with 70 gigabytes. But there's more. Like transient objects are there as well. Transient objects are objects that are very short-lived, and they're stored separately. Ariana, is that the case? You probably remember this better than I do.
Yeah, no, that's true. So the problem with I'll just try to sum this up a bit. I don't want to step over your feet, but typically whenever we try to do sizing for the caching process, we suggest to allocate no more than 80% of the RAM available on your system. And that's because together with the caching process, you have the operating system, you have the object overhead, which, as you can imagine, is an overhead per object, and it makes a difference if you have 100 objects in cache and if you have 1 million objects in cache. And then there are so many other moving parts and variables which are completely unpredictable. So, for example, if your system sees an unexpected spike of traffic and it needs to open more sockets than expected, that will consume memory. And this comes from a real case scenario where the system ran out of memory due to TCP connection and the socket being or socket setup or defaults being not properly tuned. So there is not only Varnish in the system, but there are other moving parts we don't really have a complete overview on.
And then on top of that, like you have the transient memory, which is not the same memory, but it also stores objects, with short-lived objects, and that can grow on you as well. And then if you have varying traffic patterns, the more traffic you have, the more these variables will kick in, and the more they will eat out of your headroom. At a given point in time, we've already done a number of concessions and are left with 65 gigabytes of RAM, but that headroom is not guaranteed. And then you make that crucial VCL mistake, for example, and set the TTL for all objects to a very low value, whereas the transient cache explodes, and not only is your headroom jeopardized, your entire stability is jeopardized, and your server goes out of memory and goes down. So that's something we're trying to tackle. And there's variable amounts of memory and fixed amount of memories, and that is a bit of a challenge. So the way we solve this is by using the memory governor. Memory governor is a Varnish enterprise module that will, well, not only does it have a really cool image I created, because the memory governor, it's a very cool term, but it is a solution to these variable aspects. What it does is, instead of making the total cache size fixed, we make the total process size fixed, so all in one.
Yeah, exactly. So basically, instead of allocating allocating memory for the caching process, we just let Varnish know that's the total amount of memory you can use from the system, and no matter if it is for the caching process or if it is for the objects overhead or for the transient content, just don't go beyond this quota, because that's all you can use. And then everything else will be just handed over to the kernel, to the operating system, and to the system, really. So we just set a hard limit for Varnish in total to use.
And internally, we will shrink the size of the object cache if we know or if we notice that other aspects need more memory. And it is part of the massive storage engine that we mentioned before. And the MSE, or the massive storage engine, can be configured using the -s flag. And instead of malloc, you use MSE, and you point it to a path where your MSE configuration is located. And this is the top one is what a typical MSE setup could look like in memory only mode. And what you can do is assign, let's say, 100 gigabytes to the cache, but that sets it to the object cache. If you wanted the memory governor to kick in, you just set it to auto, and then memory governor is enabled, and you have automatic memory management. By default, even if you don't use any of these parameters, 80% of memory is allocated. And you can extend it. Like you can say -p memory target is 80 or 90%, or you can use absolute values like 50 gigabytes. Even if you don't have an MSE configuration file, as soon as you use the MSE keyword, you will have the memory governor kicking in, and then you can tune it. And even if you don't tune it, all the way in the bottom, as soon as you mention MSE, with nothing else in place, memory governor will be enabled with 80% allocated. And that is a pretty cool deal. All right, number 8, do edge computing, which is a bit of a fancy term, but I still wanted to put that in there. The edge, that's the outer tier of your web platform. And that's usually your CDN layer, your Varnish layer. Quick one here, Varnish is CDN technology, just to make that official. So the outer tier is the edge, and that's where a lot happens in terms of caching. Now, there's a difference between edge computing and computing on the edge. I will talk about computing on the edge, and Ariana will talk about edge computing. This is computing on the edge, or this is rather not computing on the edge. Let's say you want to have a personalized page to serve the username somewhere in a placeholder in your header or your shopping cart. Well, you'll do that based on perhaps a session ID that is part of the cookie. Well, Varnish can't deal with that because out of the box, it doesn't deal with cookies. So in order for the personalization to happen, you will need a cache miss, and that cache miss will allow the origin to personalize the output and display. That's not really what we want. What we can do instead is say, well, we'll process the cookie on the edge, and we'll inspect that cookie, and we'll take the ID and use a data service via an HTTP API or a data service and fetch what the username is. And the origin's responsibility is just to serve a template with a placeholder where we can parse the personalized data in. So the placeholder gets cached, the template gets cached and can be served. And as soon as we inspect and we see a cookie and we can fetch its associated values, we can do that composition on the edge and basically cache uncacheable things. And computing on the edge happens using a multitude of vmods. There's so much we can do. Unfortunately, not enough time to illustrate this. But a typical use case for computing on the edge would be like fetching the HTML template, parse the placeholder, cache the template, inspect the request cookie, determine the session ID, fetch the information from that API, either over HTTP, could be Redis, could be SQLite database, could be a local key value store, and then populate all of that. So it is tremendously powerful, and it will allow you to cache the uncacheable. Another one we have, maybe you can elaborate on this one, Ariana, JSON Web Token vmod.
Yeah, I'd say this is definitely one of the most fitted example for computational power at the edge. So the JWT token is just basically a token to check the identity of a user, and without the caching power, the edge caching power, you would have to check it or let your authorization or any of your origin servers check it. But with Varnish, using one of the vmods we have mentioned in the previous slide, you can do you can do this at the edge of your architecture. So as soon as the client sends a request, Varnish can either continue the request handling, or it can just reject it if the JWT check is not successful. So that's one of the most powerful example, I think.
And your Varnish all of a sudden becomes an authorization gateway, which is a powerful use case. Now, it allows you, and I've stated it before, I'll say it again, it allows you to cache the uncachable. But edge computing, Ariana, you're more familiar with that than I am, is a bit of a different term. It uses the same ideas, but it's a bit different, and it's very much an idea that we will benefit from now, but also a lot in the future as technology evolves.
Exactly. So as you said before, Varnish is CDN software, and whenever we deploy CDNs, we typically want to have a couple of caching layers. One living closer to the origin server and protecting the origin, protecting your backends, making sure we shield them, and the other layer instead will live closer to the end users, and that's where that's really the edge of your infrastructure, and that's what we refer to edge computing. I'll give you an example. 5G is possibly the best example for edge computing. We have a few caching instances living closer to the data centers where you have the origins, and then we have many smaller caching instances being closer to the end users themselves and being distributed. So whenever we talk about edge computing, we are really talking about a very distributed infrastructure where we also apply computational power on the edge to reduce latency and try to have a latency as close to zero as possible. That's really the main difference between edge computing and computational power at the edge.
And you did mention 5G. It's a very popular buzzword that leaves a lot of people scratching their heads. But for us, we actually have implementations, and we see it as a very powerful use case for Varnish. So you'll hear more of that in the future. We're almost nearing the end. Here's a random one, a pretty short one, but yet a useful one. If you work with Varnish and your backend becomes unresponsive, Varnish will respond with a synthetic output. And this is a typical one you'll get. As soon as you see the guru meditation as part of the output, you know you're dealing with Varnish. But let's face it, this is not the cleanest way of doing business. This is not on brand. Your visual branding and the aesthetics will be entirely different. So my advice, and Ariana's advice as well, is please modify the default value. Like this is the default. This is the built-in VCL for backend error. So this is an interpolated string that is used where everything is put in. Please change this. Synthetic output, you saw that in the JSON web token example. These return statements where you deliberately return a status code and a sort of response reason, please extend that as well. This is how it's done by default. Now, here's a quick example how you do that. Not a whole lot of VCL involved. You actually reduce the amount of VCL. Instead of writing up the HTML in there, why not load it from a file? And that file can contain all the JavaScript and all the CSS and all the extra bells and whistles that you need. What you do is you put perhaps a reason placeholder in there, and we just replace it with the actual error message or the output we want to generate. And that way it looks a lot more aesthetically pleasing, and it is pretty much on brand. So it's a short one, number 9, but please do it. It will make a difference, and it will make you look a lot more professional. As a matter of fact, small anecdote, 2 days ago, I was contacted by a friend regarding Varnish because meetup.com had an issue with their backends, and that ugly page was there. So you might not want to do that. And even some of the big boys are facing these same problems. So that was 9. Let's do the last one, Ariana. Please do CLS. Let's talk about the history here. You've been part of Varnish software longer than I have, so you can talk about this.
Yeah, so back in the day, the standard for layer 7 connection was plain HTTP. We're talking about, at least 10 years ago. But I mean, nowadays things have just changed, and today really HTTPS is the new standard, mostly because it is secure, first of all, and yes, thank you. It is secure, and not only that, there are many papers out there proving that nowadays HTTPS is more performant than plain HTTP, and that's And that's the reason why in 2015 we started a project called Hitch. This is an open source project, so perhaps Thijs, you want to expand on that?
Yes, so Hitch is very much like we adhere to the Unix philosophy, and the Unix philosophy says do one thing well. And that one thing that Varnish does well is caching and performance. So we don't compromise on performance. However, the crypto bits about the TLS connection could be very CPU intensive, could be very resource intensive. So it could weigh down on Varnish. So initially we didn't want to solve it that way. And what we did instead is facilitate TLS termination. So we invented a TLS proxy called Hitch, and it's built for the job. It just does what it needs to do at very high speed. It's very configurable. And again, Varnish is facilitated or facilitates the use of Hitch. So what happens here is that you get an extra piece of proxy in front of it. You have a proxy in front of a proxy, but Hitch takes care of the crypto bits and then talks plain HTTP to Varnish. And Varnish can then examine, using the proxy protocol, as we explained, what the IP address and the protocol information was of the client. This is the Hitch configuration file. It is very flexible. It's its own thing. It defines where it should listen to, on which port, on which network interfaces. It also defines where Varnish is located. You can enable the proxy protocol. You can define where certificates are loaded, and then all the crypto bits, the cipher suites, the protocols, and all the extras, you can tweak that as well. So it's a pretty damn decent tool, and we still use it to this day. We're very proud of it. And I mentioned the proxy protocol. Can you elaborate on proxy, or should I do this, Ariana?
As you prefer, but really the point is that whenever we work with a Hitch, we are adding another process in between the end user and Varnish, and Hitch will take care of terminating a HTTPS connection. But then of course we as Varnish, we want to make sure we keep the original client IP, because most of the caching decisions are based on the uniqueness of the client. And that's really the role of the whole proxy protocol, whose goal is to make sure that Hitch can pass the right amount of information to Varnish, so that Varnish can indeed then elaborate the request as it was originally sent.
Well,
So
there's
Varnish will
a very simple example here. Like a lot of applications, your typical WordPresses and Drupals will be protocol aware. So if they know HTTPS isn't used, like you have a plain HTTP connection, they will force a redirect to HTTPS. But since Varnish is only accepting HTTP, you'll always have that continuous loop. So what you can do is you can extract using vmod proxy, which I showed 2 times before. You can inspect whether or not the original connection was made over HTTPS prior to being terminated. And you can use that to set an exported proxy header or exported proto header rather. You'll have the right IP address automatically being stored and exported for. So it's a very significant one, and it softens the blow for adding this extra layer. And as a matter of fact, here it is. Here is the logic to set the exported proto header, which is automatically checked by a multitude of systems. And we're very proud to say that this system can take more than 100 gigabits per second on a single server. And this is HTTPS, by the way. And this is an announcement that I'm not sure if we've made it officially. I think this is a first. We have official packages for Hitch as of recently, and it's under the Varnish Cache namespace. So if you're on Debian, Ubuntu, CentOS, Fedora, Red Hat, you name it, you can have official packages that are maintained, containing the recent version, systemd startups, you name it. Now, the final piece of the puzzle here before we leave you be is a very recent announcement. With recent, I mean, I think, what was it? Earlier
3 months ago
this year. Was it 3
Yeah.
months ago? Only 3 months ago. Wow.
I'm not sure. The quarantine has had some effect on me, so I'm not sure about time anymore.
But what it does is it takes that decision of terminating TLS elsewhere into Varnish, and there were specific reasons for that. Now, what happens is you don't need Hitch anymore. Like HTTPS connections are directly accepted on Varnish. And for that, ironically, we're getting rid of Hitch, but we're still using the subset of its configuration mechanism. So you could take that typical Hitch configuration file. We've omitted the parts where you talk to backends or where you mention proxy protocol because you don't need them anymore. But even if you put them in, we will ignore them because they're not bothersome. And then this is how you enable it. This new parameter -a uppercase. Big warning here, this is a Varnish Enterprise only feature, and it allows you to handle TLS locally without the need for Hitch. And you've been involved in these, right, Ariana, in these benchmarks?
Yes, that's really good. I have a couple of numbers I would like to share. So we do software for performances, of course, and we do test it. And at some point, we benchmark built-in TLS on optimized CDN hardware, and we consider several use cases. But our goal is always to make sure we can saturate all the bandwidth we have available. And nowadays, the biggest network cards you can get are 200 gigabits per second, and that's where we run the benchmark on. And in the worst scenario we tested, which would be 80% hit rate, which means that 80% of the requests were served out from Varnish, and that's a real life potential hit rate. It's not unlikely that if you're caching, you get 80% hit rate. Out of the 200 gigabits per second available, we managed to saturate 159 gigabits per second. That's roughly the 80% of the network cards available, and we kept a latency close to 30 milliseconds. In the very best case instead, and that will be 100% hit rate, we saturated 188 gigabits per second out of the 200 available. That's close to 95% of the available bandwidth, still keeping a latency close to 30 milliseconds. I mean, saturating anything between 80% and 95% of the available bandwidth is a stunning result in my
definitely, because usually it's other systems.
opinion.
Yeah, because usually it's other things that give up earlier. You run out of CPU, you run out of memory. Well, Varnish is so powerful, and the way we've implemented it, you can actually saturate the network card. So that's about all the time we have for today. Those were 10 do's and don'ts. And I'm pretty sure we'll recycle this format because there's so much to talk about. We'll find 5 other don'ts and 5 other do's, and we'll invite you back for the next one. That being said, thanks a lot for being part of this. Thanks a lot for taking the time out of your very busy schedules. And I hope to be seeing you next time. We'll stick around for a couple of minutes for questions, which you can post in the question part. And we will be talking to you very soon. Thank you. So we have some questions here in the list, and I'll be go over some of them. One of the questions we had is there a counter in Varnish Stat to view or to know how many requests are in the waiting state? Ariana, do you know this?
I don't remember that by heart. I can check it.
Me neither. So what I suggest we do is, like, we're being honest, like we don't know this by heart, but we'll look it up. So I suggest we keep track of all the questions, and we will provide responses. You also have our email addresses here. You could still see my screen. So please, by all means, send us an email if you have additional questions, but we'll keep track of those. Then another one. Where can we look into the default VCL? Is it shipped with the Varnish package? The answer is yes. And there's even an easier part. If you go to the GitHub page of Varnish, so you go to github.com/Varnish cache, and then you go to the Varnish cache repository. In I think it's the bin folder, there's a Varnish D folder, and in that folder you'll find a file called built-in.vcl, and that contains all the built-in VCL. Now, don't worry, we promise you it's a safety net. So even if you don't write it, it is still there. What else have we got? Is there anything else you can add to the disk option on open source besides don't use it? Or are there any best practices?
That's tough. I'm not really aware of any best practice here.
Me neither. We've heard from people using it that after a while it is a bad idea to use it. Like maybe on smaller setups you can, but I have to be perfectly honest with you as well, because we work for Varnish software, so we have a little bit of a commercial agenda in here. So we tackled the issue years ago with massive storage engines. So all we use to tackle these problems is the massive storage engine. So the advice I can give you is give it a try, give it a spin. If you're not a Varnish enterprise user, if you don't have a license and you still want to play around with it, you can. And we have images on the cloud, on AWS, on Azure, and on Google Cloud. We have those available, and you can play around with it. And if it pleases you, if you like it, and if you need it, you can still get in touch with us. Will the slides be made available to the attendees is another question, and the answer is yes. We will. I will even try doing that today. We'll create a PDF out of this keynote slide deck, and I think the people from marketing will then send it your way. More questions? What is the advantage of using Hitch over HA proxy? I like that question because it fits into the Unix philosophy quite a bit. HA proxy, out of the gate, one of my favorite load balancing systems out there. But again, it carries that extra weight. It has that functionality of being a load balancer. It carries a little bit of extra weight. If you're talking about pure TLS termination, Hitch is lightweight. It's a lot more lightweight and maybe a bit more powerful. But if you already have HA proxy in your stack, by all means use HA proxy. Because as a matter of fact, HA proxy invented the proxy protocol. So if you talk about proxy protocol support, HA proxy definitely has it. We tend to prefer Hitch because it's more lightweight and we have more control over it. We have a question that wasn't really a question, but someone who said thank you. Well, you're most welcome, and we hope to welcome you in the future. Do you provide us with the sheets? Probably mean the slides. Yes, we will. We talked about skipping the built-in VCL. How is that done? How do you skip the built-in VCL? Well,
not telling you.
Well,
no, just kidding.
Yeah, it's pretty easy. Like maybe we should just show. I'm gonna show a slide here. You see all these return statements. That is how you skip the stages. Like if you write custom VCL, maybe you should take this one. Maybe if you have specific cookies, you do want to explicitly return hash. This is how you change the state. Like you have to make sure it's done before you hit this one. So if you have an empty page and an empty VCL receive, you do your logic, you do return hash or return pass. And for parts you don't return on, the built-in will kick in. So as long as you don't return, built-in will kick in. If you do return, you're in control yourself, but you have to deal with the consequences. Last one, last question. Could I have Varnish drop a malicious URL? The answer is definitely yes, and there's many, many ways to approach this. From an open source point of view, you can check for patterns, both in the URL or maybe in other headers, and then do a synthetic return with a 403 or a 400. But if you want a little bit more intelligence, we do have a module on the enterprise version, of course, that does web application firewalling based on mod security, if I'm not mistaken. Am I right?
Yes. Yes. And the 10 default always rules really. So you install it and you get protection for the 10 most common attacks or yeah, malicious users really.
All right.
It is mod.
All right. Great. I think we're going to wrap it up. We're a bit past our curfew here. And another question I saw here is, will this be made available on demand? I'm pretty sure it will. And it will be as a private YouTube video. And if you signed up, you will get the link. So after we've edited this. So have a pleasant evening, everyone. Thank you for checking us out. We will be back with more like this. And until then, have a pleasant evening and stay safe.
Thank you very much for your time. Bye, everyone.